Let us start. Let us consider a copper wire. Its length is 1 meter long. Now potential difference is applied to the ends of a copper wire. It is 100 volts. So next, drift velocity we have to be find out, and we have to that compare with the RMS velocity, means thermal velocity at 27 degrees Celsius. Next, electron, conducting electron per atom is given. Per one atom there is a one conducting electron. Next, the mass of copper is given 63.5 grams. The next, density of copper is also given, and Avogadro number is also given, and conductivity of copper is also given. Boltzmann constant is given. Let us find out the solution. The number of the copper atoms, Kaplan equal to Avogadro number 6 into 10 to the power of 23 atoms. Mass of the copper they have given. The mass of the copper equal to 63.5 grams. We are converting to kgs. 63.5 into 10 to the power of minus 10 to the power of minus 3 kg we get it is. Now there is a one conduction electron per an atom, means one atom donates one conducting electron. Now the number of electrons per unit volume, the number of electrons per unit volume, n equal to Avogadro number divided by mass of copper into the density of the copper. Let us substitute their values. Mass of Avogadro number 6 into 10 to the power of 23, mass of copper 63.5 into 10 to the power of minus 3, density of the copper 9 into 10 to the power of 3. So after these all calculations we get 8.5 into 10 to the power of 28 per meter cube. This number of electrons per unit volume we calculated. Next, let us find out the electric field. E is equal to V by L, 100 by 1. So equal to 100 by 1, we get 100 volt by meter. Next, J, current density. J equals sigma into E equal to NE, drift velocity by drift velocity. From this, drift velocity equal to JE by NE. Let us substitute their values. Conductivity of copper already is given in the problem, 5.81 into 10 to the power of 7 into electric field we calculated 100, and number of electrons per unit volume 8.5 into 10 to the power of 28 into charge of electron 1.6 into 10 to the power of minus 19. After all calculations we get 0.43 meter per second. Now let us find out the thermal velocity. Let us find out thermal velocity. So Vrms is equal to the formula root of 3 kb into capital T divided by mass of electron. Now here 3 into Boltzmann constant 1.38 into 10 to the power of minus 23 into, so they are given temperatures 300 Kelvin after conversion. So mass of electron 9.1 into 10 to the power of minus 31. After calculation we get 1.17 into 10 to the power of 5 meter per second. So we know drift velocity, we know RMS velocity. Let us compare. The drift velocity by RMS velocity is equal to 0.43 divided by 1.17, and finally we get it is 1.17 into 10 to the power of 5. We get finally 3.67 into 10 to the power of minus 6. That's the answer.